Hi and welcome everyone. In this video, we are going to demystify the O in the solid principles, which is also called open-close principle. Let's have a look at the definition first. By definition, a class should be open for extension and closed for modification. When applied well, further changes of that kind are achieved by adding new code, not by changing old code which already works. Note a very important detail here. Code changes of similar kind. Let's break the definition into two separate parts and try to understand them one by one. The first one says classes should be open for extension. This means that you model your features in such a way which requires you to define a clear contract and you stick to it. This requires a lot of thought before implementation. Once the contract is clear, this is exposed by an interface or an abstract class and not the concrete implementation. This is done this way because it allows you to provide a different implementation for the interface, which allows you to dynamically change functionality at runtime. I call this art. Isn't it beautiful? The second one says closed for modification. This is pretty straightforward. The concrete classes you have created in the first part, you don't modify them at all, because to achieve new functionality you can just create a new class for the similar separate feature. Also, this is only applicable when you want to add a similar kind of feature. If you have foreseen this, you can create an interface at the first go itself, but that violates Yagni principle, which says you're gonna need it. But you can take a decision after reading your requirement specifications for your feature. Also, there are scenarios when you need to add more methods to the existing contract. Now, this is a little tricky because it does and also does not violate the open-close principle at the same time. Let's see how. If you add more methods to your interface contract, you're breaking all the existing implementation of classes you have implemented before, because you need to provide a functionality for the new methods in those classes. This is not a problem if your implementation classes are living in the same code base. But the problem arises when your implementation classes are living outside the module or the project itself. Those will break when you update your contract. So to overcome this, Java has a feature to add new methods to the interface and still keep older classes from breaking. And this is done by providing default methods to the interface. I'm sure other languages will also have something similar to this. This allows your interface to be backward compatible. So in this case, as long as you're not breaking the existing contract with the older version of interface, the open-close principle is not violated. Let's have a look at how the code looks without the open-close principle. The left side of the image shows a graphical representation of the older version of code. And what happens when you try to add new feature or similar type of feature to your existing code? You merge these together at one place, and this violates two principles. The single responsibility principle, since now your method is doing more than one thing, and the open-close principle, because you just modified your class to achieve a similar type of code. And this leaves room for more modifications in future if similar requests come again. So let's see how we can do this better. Here we have the same example, but this time we have taken a different route to implement this feature. Instead of adding code for new similar feature in the same method, I have created an interface for the client which the client can talk to. And based on the type of argument, we can use polymorphism or some dependency injector like Spring to inject the correct dependency and get the concrete implementation of the required subclass. This way, if any future request with similar kind of feature is required, then you can just add a new class for it and do not need to edit the older ones. This has following benefits. You don't have to modify your old unit tests since your old code didn't change at all. You're free for adding any new feature just by adding a separate class. Again, see, we are not modifying, editing or deleting an existing class to achieve something new. We're just adding. So here are some advantages of open-close principle. Your old unit test cases don't need changes. Writing unit tests for your new code is very simple because you just need to add a separate test class for your unit test. This also helps you achieve single responsibility principle, as now you're breaking the functionality into separate classes and each functionality sits in its own class. So every class has one responsibility. This also opens a way for Liskov substitution principle to be implemented, and we'll talk about that in a later video. Similarly, it also opens up the way for interface segregation principle and dependency inversion principle, and we will see those as well in later videos. So I wish you believe that it's a very powerful concept and can save you a lot of headache while programming and writing tests. That's all I had on open close principle. Goodbye.